Okay, today we're looking at the notes for 5.2, verifying trigonometric identities. Can you verify trigonometric identities and determine whether equations are trigonometric identities? This is a recording for Friday 5.5. It is the first part of section 5.2. You'll see that we are spending a lot of our time right now using these things that are on our note card. And even though I have them on the wall here, it's probably a good idea to be looking at them on your own note card so that as you're taking a quiz or something, you're familiar with where on your note card you have written things that you need to use. So take a moment, set up the heading there, and then we will verify some identities. Okay, so here's the deal. The only difference really between section 5.1 and 5.2, so if you missed any time during 5.1, 5.2 is like a continuation. If you take these with the correct attitude or a good attitude, essentially in the last section, your job was to simplify an expression, right, to make it simpler. Well, in this section, you can think of that as the book author's giving you the simplified version, and you have to show that the longer version kind of can be equal to that. So if you take it with that attitude, it's like it's just going to be a little bit easier. But what we're truly doing is verifying an identity, and there's a big rule that we have to know as we go through verifying identities, and that is the word used here is prove, but truly all you're doing is working with one side. It's not like that geometry proof of, two columns where you're giving statements and reasons, and you're not giving reasons for anything. It just has to logically follow as you go through the rules. So to verify an identity means to prove that both sides are equal for all values of the variable for which both sides are defined. So it is within the parameters of it being defined. So that is one thing to keep in mind. A huge rule in this is you can never cross the equal sign. And that's what makes this so much different than like solving an equation. If I gave you an equation like 2x plus 5 equals 20, you would right away subtract 5 from each side of the equation, right? And that's kind of the mode of operation that you'd use. But here we can't cross that equal sign. We just have to work with something on one side or the other side and show that they can be equal to the same thing. You'll find it's often easier to start with the verification of a trig identity by beginning with the side that's more complicated and working towards the less complicated side. And we'll even do a strategy where maybe both sides seem kind of complicated and we don't know which one to start, but we might like work with the left side for a little bit and work with the right side and until we can get them to be the same thing, and then kind of back right one of those sides so that it goes from one side to the other. So that's an important thing to keep in mind. And instead of justifying step by step, we're just using all of these things that are on our note card because we know those are things that are correct as we go. So we'll just jump right into this, and when we start going through this one, you will find these use a bit of paper, and the deal with this is you are proving something, so you have to go sequentially and you're not crossing the equal sign. So generally we're working straight down a side as we go. And I'll always just rewrite the problem. So tangent squared x plus 1 over 1 minus sine squared x equals secant to the fourth x. And I will just comment because this came up yesterday and I am recording today. Just a reminder that the fact that sine squared x really means the sine of x times the sine of x. And so it's not sine times x times sine times x or something. It's the sine of x times the sine of x. This is just our notation way of writing that. So just a little reminder from last time. Now, I can't cross the equal sign. It should be obvious to you that this seems to be the more compact, simplified side. This seems to be what we're working on. And so if you approach this as if it were a problem from the last section, you could just do this. Pretend, and I'll pretend by just blocking this out. I'll maybe need a little bit of color there. So I'll pretend I don't have that. And yesterday's problem would have said simplify that, right? And this would have been the answer to that simplification. And so now, in a way, it's like they're telling us the answer. So we're going to just kind of go through and show that those are the same. Now, what that also means is when you do these homework problems, there's really very little to correct at the end because either you got it to work out or you didn't get it to work out. And so questions should be, I couldn't get this one to work out. How can I figure that out as I go? So as we're looking at this, when I look at these two expressions, what do you think I'm looking at on my on my little note card there? The Pythagorean identities, because both the numerator and the denominator have the number 1 in them, and plussing or minusing, adding or subtracting, and some squared function. So one of them is direct. Tangent squared theta plus 1 equals secant squared. So in my little think box, especially because when I'm recording this, you know, people can't see what I'm pointing to on the wall here. The tangent squared theta plus 1 equals secant squared theta. So that's one identity, and I'm going to use that for the top. Then on the bottom, I have 1 minus sine squared, but that comes from sine squared theta plus cosine squared theta equals 1. And so if I subtract sine squared, I get cosine squared theta equals 1 minus sine squared theta. So Austin, tell me what I'm going to do. And are you in agreement that I'm going to work on the left side, correct? And then what are you going to change that left side into? So tangent squared x plus 1 is going to be replaced with what? Secant squared x over, and 1 minus sine squared x is going to be cosine squared x. And then I want it to be secant to the fourth, so I feel good because I have secant squared there already. Remember a strategy we said yesterday, so we're using the same strategies, just doing a little different problem. And so I'm going to separate this and say this is the secant squared x over 1 times 1 over cosine squared x. And the secant squared x, I'll even just write that that's just going to be secant squared x. And 1 over cosine, what kind of thing off of my note card am I going to use now? My reciprocals. And remember, we said those reciprocal functions can be used to any power. So I'm going to use the one that says 1 over cosine theta is equal to secant theta, or secant theta is equal to 1 over cosine theta. And so then when I do this problem, this is 1 over cosine squared theta. And so I'll put in my think box there, secant squared theta is 1 over cosine squared theta, just to kind of notice that I'm doing that. And so then this 1 over cosine squared is secant squared theta. And then secant squared theta times secant squared theta. Oh, excuse me, I made it theta instead of x. Yep. And secant squared x times secant squared x is secant to the 4th x. And as long as I get that to be, and I just usually put a check mark. To me, that means that, yes, I just got secant to the 4th, and it's the same as that. And so that's one problem that we're working on. And so hopefully you can see that really, just by going over some more of these problems, this next section isn't a lot of new stuff for us. It's just a continuation of what we have done before. So we're going to do one more problem, and then we'll have some work time today. So this is number 2. Verify that -2 cotangent x is equal to sine x over 1 plus cosine x minus, and I'm actually just going to leave a little luxury room because I feel like I'm going to get a common denominator. So I'll just set this other one a little further away. 1 minus cosine x. So, Adam, do you think I should start with the right side working or the left side? The right side, because we know things we can do here. This is just kind of would be a guess of what we would try to do. And any thoughts on how to get a common denominator? Lewis, what are we going to do to get a common denominator? Okay, our common denominator is going to be multiplying the bottoms together. So this one's 1 plus cosine x, so we're going to multiply it times 1 minus cosine x. And so we don't change the value. We'll have to have 1 minus cosine x over up on the top there as well. So that's a strategy we used yesterday as well. And on the second one, it's already 1 minus cosine x. So I'll multiply times 1 plus cosine x on the top and the bottom. And I'm going to get something kind of long here. So I think I'd like to just distribute through that and just give you a head nod right now. Do we all understand that I can write this as a single fraction with 1 minus cosine x times 1 plus cosine x as the denominator? Just give me a little head nod so we're good with that. Okay, so that's what I'm going to do. I will just write that as 1 plus cosine x times 1 minus cosine x, and just kind of leave that for a moment. And then, Emily, will you just distribute sine x times each of those? And then maybe I'll write this as plus and negative, do you know what I mean? So that when you distribute that one, you're distributing a negative sign. You ready? Okay, go ahead. And just read both. Cosine x, sine x, yep. Okay. So notice anything good that's going to happen to us there, Emily? Yep, the sine x's cross out. And what happens with our cosine x, sine x's? They combine together and I get -2 of them. That makes me super happy. Does it make you super happy? Because look over here. What do I want to end up with? I want to end up with a -2 something. So when I get a -2 something, I'm like, ooh, feeling like I'm on the right track. Do you know what I mean? And so that helps me kind of think that I'm going to get someplace that I want to go. So -2 cosine x sine x. And By the way, let me just kind of comment on this. Could Emily have said these as sine x, cosine x? And what if she just said one each way? Are they still like terms? Yeah, so just keep in mind as you're writing things out, you know, that when you multiply two things, you know, cosine x, sine x, or sine x, cosine x, those are like terms, even if you write one backwards to the other one as you go. FOIL this out for us, Sarah. Nah, you can just tell me the answer. 1 minus cosine squared x. Remember, this is a conjugate pair. And so they gave us a conjugate pair, but always keep that in the back of your mind that if you need to do something with a fraction, use a conjugate pair. Because what am I going to be able to use for that conjugate pair as I look at it? Janet, where am I going to get something that I can use with this off my note card? Well, I've got a 1 and a cosine squared. A Pythagorean identity. So I'm going to be able to use a Pythagorean identity for this one, and I think that's going to help me because I don't want added and subtracted things. That's another clue for my answer right there. I'm going to put my think box kind of right here in this little spot. And Janet, which Pythagorean identity are we going to use? Just read it to me. Here's what I need of those three. Which one? Okay, and then to get 1 minus cosine squared, I'm going to subtract that. So sine squared theta equals 1 minus cosine squared theta. Then we'll do this substitution, -2 cosine x sine x over sine squared x. And I don't quite want to lose my -2 cotangent x. But what can I do right now, Austin? What's something I can do? Yep, and so be careful when you're canceling a sine x with a sine squared. On the top, I can cancel off the sine x. What do I cross off on the bottom? Just the 2, right? And so, you know, and if you're uncomfortable with that, just remember sine squared x is sine x times sine x, and you could write it like that and then cross one of those off. Now, I think I'm almost done because hopefully cotangent is equal to something over here that I have right there. Give me a head nod, is it? Yes. And so where is it? Someplace here. Cotangent is cosine of theta. So cotangent theta is equal to cosine theta over sine theta. And so I'm going to just replace all that. -2 cotangent theta. Thank you. X, not theta. So I felt like doing 2 problems today. Really, if you're working on homeworks in section 1, it's like this same stuff, right? Do you agree with that? You know, a lot of this same stuff. But in section 2, it's like they give you the answer and you have to get to that answer. Okay, so we have the rest of our time today to work on these, and I will let you